Hello everyone, welcome back to the playlist of numerical methods. In the previous video, we have understood what is Newton's forward and backward interpolation method. In this video, we will purely use the formulas we have derived in the previous video and directly apply them on the questions. Let us recall the Newton's methods first. Initially, we will be given some tabulated values of the function fx corresponding to some discrete set of values x, and the table will look like this. And in the last video, we have seen what is forward and backward differences, and after understanding that differences, we have made a note which helped us to calculate the value of forward and backward differences. And that note is like this. After that, we derived Newton's forward interpolation formula. We will directly use the phi n equation, which will be useful in finding the Newton's forward interpolating equation. And that equation is like this. We need to understand that this formula is used for interpolating the values of y that are near the beginning of a set of tabulated values and extrapolating values of y a little backward, that is to the left of y0. Only then we are going to use the Newton's forward differences interpolation formula. Let me write it down for you. Similarly, let us recall what is Newton's backward interpolation formula. And in the same way, this formula is used for interpolating the values of y that are near the end of a set of tabulated values, and also for extrapolating values of y a little ahead of yn, that is to the right. Let us write it down too. Now let us understand this method with the help of the examples. The questions of Newton's forward and backward differences are quite easy than their derivation. Question number 1 says, to fit a polynomial of degree 3 which takes the following values. By default, we are using Newton's forward or backward differences interpolation formula here. Since we are not asked to predict the value of y at some point, so we can either use Newton's forward or Newton's backward formula. Let us try this question with the help of forward differences table. Since we need to find a polynomial of degree 3, then we have to go till difference 3. For the first difference, forward y, this value will be 24 minus 6, that is y1 minus y0, which is equals to 18. And then the next value will be 60 minus 24, which will be 36. And the next value will be 20 minus 60, which will be, make a correction, there is 120, not 20. So 120 minus 60 will be 60 again. For the second difference, we will subtract 36 minus 18, that is equals to 18 again. And for the next value, it will be 60 minus 36, which is equals to 24. And we will be left with last difference, which will be 24 minus 18, which is equals to 6. This is my forward difference table till now. And from this table, we can see that the value of x0 is equals to 3 and the value of h is always 1 here. And the corresponding y0 value is 6. And if y0 value is 6, Then forward y0 will be 18, forward square y0 will be 18, and forward cube y0 will be 6. Let us use the forward difference interpolating polynomial first. Generally it says the phi n value is like this, but for this question this will reduce to 3, which will be equals to y0 plus forward y0 divided by h into x minus x0 plus forward square y0 divided by 2 factorial into h square x minus x0 into x minus x1 plus forward cube y0 divided by 3 factorial into h square, h cube, here is also cube, into x minus x0, x minus x1, x minus x2. This will be all. Now we have all the values of xi's, y0 and forward y0's also. Using those values, this equation will be, after simplifying, this equation will become, which will be equals to x cube minus 3x square plus 2x, which is the required polynomial of degree 3. And we can see that solving a question based on Newton's forward difference interpolating polynomial is not that difficult. We just have to construct the forward difference table, then use this formula and start putting the values. All we have to remember is just this equation phi nx. Let us try one more question, which says to estimate the population for 1895, and we can see that this value lies between x0 and x1, which is close to the beginning of the set of tabulated values. Therefore, we have to use Newton's forward difference table only. Starting with the forward difference table, the first forward difference will be 66 minus 46, which will be 20, and the next forward difference will be 81 minus 66, which is 15, then 93 minus 81, which is 12, and in the last 101 minus 93, which is 8. For forward square y, it will be 15 minus 20, which is minus 5, 12 minus 15, that is minus 3, and then 8 minus 12, which is minus 4. For forward cube y, it will be minus 3 minus of 5, which is 2, and minus 4 minus 3, which will be minus 1, and we are left with only one term, which will be forward 4 y, which will be minus 1 minus 2, which is equals to minus 3. Again, from the question we are given the value of x0 as 1891, implies the corresponding y0 value will be 46, and the value of h here is 10, and the corresponding values of first forward y0 will be 20, second forward y0 will be minus 5, and third forward y0 will be 2, and fourth forward y0 will be minus 3. Using all these in the equation, phi n x. This equation will reduce to phi 4x is equals to putting the values of y naughts and forward y naughts and xi's in this equation, which will become, since we have to find the value of y in the year 1895, we are not asked to find the polynomial in this question, rather we have been asked to estimate the population size for the year 1895. So rather than solving this equation in the form of x, we can directly find the value of phi 4 at 1895, which will simplify all the calculations, and the final answer will be 54.853 thousand. And this answer have been rounded off to 3 decimal places. Let us move to the next question. In this question, we are not directly given the tabulated form, rather we have given some values. Let us manipulate these values and convert it into the table. Let us assume that u of x is in the form of summation x to 20 f of x. And why we have considered it? Because in the question we can see that the minimum limit of the summation is changing, but the maximum limit of the summation is always 20. So we have varied the minimum term. If we have let u of x is in this form, then u of 11 will be equals to summation 11 to 20 f of x, which is already given in the question as 44060. Similarly, u of 14 is equals to summation 14 to 20 f of x, which is 38220. Similarly, u of 17 is equals to summation 17 to 20 f of x, which is equals to 27178. And finally, u of 20 is equals to summation 20 to 20 f of x is equals to 8450. Converting this in the form of table, it can be written as x and u, where the value of x is 11, 14, 17, and in the last 20, and the corresponding u values are 44060, 38220, 27178, 8450. Since in this question we are asked to find the value of f at point 11, which is in the beginning of the table, so we have to use the forward difference table only. The corresponding forward difference table will be, the first forward difference will be u1 minus u naught, which is equals to minus 5840, and the next value of this column will be y2 minus y1, which is equals to minus 11042, and the next entry will be y3 minus y2, which is equals to minus 18728. The next difference column will be forward u1 minus forward u0, which is minus 5202, and the last entry will be forward y2 minus y1, which is minus 7686. and third difference column will be simply minus 2484, where we had subtracted forward square u1 and forward square u0. So this is my forward difference table till now, and in the question we have to find f of 11, which is equals to summation of 11 running to 20 f of x minus summation running from 12 to 20 f of x. In this way we will be left only with f of 11, and the values of summation running from 11 to 20 f of x is u11, and the value of summation running from 12 to 20 f of x is u of 12. U of 11 is already known in this table, but the value of u12 is unknown. Therefore, to find the value of u12, we take the value of x0 as 11, and the corresponding u0 value will be 44060, which is here. Therefore, first forward u0, second forward u0, and this is my third forward u0. Using all these values in the Newton's forward interpolation formula, which is this equation, and this equation will change into phi 3x, which can be equated as u of x, is equals to, putting all the values in u of x including 12, because we need to find the value of u at point 12. We are not interested to find the final polynomial, so we will directly use the point 12 in this equation. So this equation will transform into, and the final answer will be 42538. Since we were interested to find the value of f11, which we have seen that it is equals to u of 11 minus u of 12. U of 11 is already known to us, which is 44060, and the u of 12 value turns out to be 42538. So the final answer will be 1522. Let us move to the another question. Now this question is interesting. This question says, from the following table, we have to estimate the number of students who obtained marks between 75 and 80. But the table we are given is not in the form of discrete values of x. So firstly, we have to prepare a cumulative frequency table, which will be as marks above 35 but less than, and the corresponding number of students. This will be treated as x and this will be treated as y. Firstly, 45, 55, 65, 75 and 85. The number of students who have marks above 35 but less than 45 are 18 only, and the number of students who have marks above 35 but less than 55 will be 40 plus 18, which will be 58. Similarly, less than 65 will be 122, 172 and 200. Now we have find the simplified tabulated form which is required for the Newton's forward or backward interpolation formula. But in the question, we are supposed to find the marks between the range 75 and 80, and this range lies in the end of the table. Therefore, we have to use the backward difference interpolation method here. And you can clearly see that it is not mentioned in the question if we have to use Newton's forward or backward interpolation method. We have to understand on our own according to the question which method needs to be applied. Starting with the backward difference table, first backward difference will be calculated in the same way we have calculated the forward difference, which will be 58 minus 18, which is 40. And the next term of this column will be 122 minus 58, which will be 64. Then 172 minus 122, which will be 50. And 200 minus 172 which will be 28. Similarly, calculating the second difference, the value of xn is equals to 85 and the corresponding yn value is 200 and the value of h here is 10. Therefore, using this as yn, this will be my backward difference yn, second backward yn, third backward yn, and fourth backward yn. Using this in the backward interpolation formula, which is 54xn is equals to, since we know all the values here and we are interested to find the value at 80. Why 80? Because in the question we have to estimate the number of students getting marks between 75 and 80. So directly using the value x as 80 here, which will be y of 80 is equals to, after solving, this value will be approximated as 188.08, which is similar to 188, as number of students cannot be in fractions. So number of students getting marks less than 80 are 188. Therefore, number of students getting marks between 75 and 80 is equals to 188 minus number of students getting marks less than 75, which are 172. So the final number of students will be 60. I hope you have made an understanding how to solve these kinds of questions and when to apply which method. I have tried to cover each type of the questions in this video, and here are some practice questions for you all. I hope you can all try these questions with full confidence. And if you still have any doubts, please let me know in the comment section. And if this video is helpful to you, then don't forget to share it with your friends. Happy learning!